Hello and welcome to this new video in the Learn C# series. Today we're going to be talking about loops, but before we go on with that, I first want to introduce you to what we're doing. If you're new here, I have an upcoming internship this summer where I need to know C#. I find the best way of learning is actually through teaching, so I'm going through the C# 12 in a nutshell book over on O'Reilly Media, going chapter by chapter and presenting some of the concepts over in that book over here on YouTube. So hopefully both you and I learn something from it. With that out of the way, let's go ahead and set up and motivate why loops are needed. Alright, so let's say that you walk into your job one day, you're still a novice programmer, and your manager comes to you and says, hey, I need you to write a program that prints out to the console 1 through 10, like we're counting up. And you say, not a problem, I can get that done in 5 minutes. So you go walk back to your desk, you sit down and you type and you say, write line 1, write line 2, write line 3, all the way to 10. You turn this program back in to your manager and your manager says, actually, I think we need to count down instead. And you say, okay, not a problem, I'll fix it. Now, instead of it taking you 5 minutes to write this, it's going to take maybe a little bit longer or shorter, depends on how you can write your code, but you're gonna see that it kind of becomes a pain. So we go to this first line, which is 1, but now your manager says that needs to be 10. So yeah, we just add a 0 to that. But then we have to delete this next line, change it to a 9, go to the next line, go to 8, 7, 6, and we keep going and counting down. But that was kind of a lot of refactoring, and this also takes up a lot of lines in our program. It's 10 lines to write 10 different things to the console. That's where loops can help us scale our programs and make them much more readable. So to start by solving this problem, let's look at the while loop. A while loop can help us solve this problem pretty quickly if we use it in conjunction with an array and some sort of variable that's going to handle the index that we are at in an array. So let's go over the basic syntax of how a while loop runs. So we're going to use the keyword while, and then within this we can pass in some sort of Boolean expression or just a Boolean value that will say, while this is true, I'm going to continue looping through this. So for now, we're just gonna put true here and then open up the braces like we're writing a method, and that's all you have to do. This is your while loop. This would technically run forever because it's while true, but at the same time, it wouldn't do anything. Let's go ahead and write a write line statement just so you can see that this doesn't stop. So if we did write line 1, we go ahead and run our program. We'll see that it's just running. It goes on. I mean, I can just sit here, scroll forever, and we can see that the executing down here just continues to execute. There's nothing for us to break out of this loop. But back at the problem at hand, where our manager wants us to write 1 to 10 and then from 10 back to 1, let's go ahead and create an array for us to help solve this problem. So we can go ahead and say int array, which is our data type that we're gonna use, and we're just going to say array, and we're going to set it equal to these braces, and we're just going to put in the numbers here. So here we have the numbers 1, 2, 3, 4, 5, blah, 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 all the way up to 10. This is our integer array. And we want to print starting from the beginning all the way to 10, and then I'll show you how we can decrement and go from 10 all the way back to 1. Let's go ahead and create an index so we know where we are in the current array. So I'll just create an int I and set it equal to 0. In our while loop, the condition that we can have is while I is less than the array's length. Now remember, the array length is 10. So this is index 0, index 1, index 2, and we get all the way up to this index, which is actually index 9. It's not index 10 because remember, everything starts at 0. And so if I starts at 0 and this exits, once we hit the array's length, we will only iterate through indices 0 through 9. So now we can do a whole entire write line statement that just prints out the array where I is currently at. So we can put array sub I and then close off. Now this is fine and dandy, but there's one thing that we're missing. We're never updating I. I will always just stay at index 0. So we need to go ahead and increment it by just doing an I++ right here at the bottom. And so let's go ahead and try this program out. So we print, and there we go. We get 1, 2, 3, 4, 5, 6, 7, all the way up to 10. This is much more succinct than what we did earlier, where we had manual write line statements line by line. And then if we wanted to change the order of them, we actually had to physically change those lines. Now, in the context of the manager coming back and saying, hey, I need you to write from 10 to 1 instead, not a problem. We can easily fix that. We don't even need to change the array unless the manager is saying, hey, I need you to change the contents of what we are printing, then that becomes sort of an issue, right? But let's keep the problem simple and say we need to print from 10 back to 1. Well, we can go ahead and set I equal to the array dot length, or well, it's with a capital L, so array dot length. Now remember, the array's length is 10 and we can't access index 10, so we need to say minus 1. We also need to change this condition right here. Instead of it being I is less than the array's dot length, I must be greater than or equal to 0. So we make sure that we're never hitting the -1, index -2, and so on. So we can still go ahead and print the array line at I, and we just need to change this condition to a minus. Let's go ahead and run the program to make sure that we're going from 10 to 1 now. There we go. It prints from 10 all the way down to 1. And let me just go ahead and show you what if we forgot to make the boundary at 0. Let's go ahead and make it -1. We're going to get an index out of bounds error, which there we go. We get our index was outside the bounds of the array with our index out of range exception. So let's change this back to what it should be. Remember, we can pass in any Boolean expression in between the parentheses of the while loop. It doesn't have to be a single condition where it's I is greater than or equal to 0. We can also combine it with a double ampersand saying this condition must be true and the other condition must be true. So we can also just write true. Now this doesn't really make any sense. We should just have the I is greater than or equal to 0. But just for instance, I'm just demonstrating that we can have multiple conditions here. And if we were to actually say and false, this while loop is never going to execute because both of these things are not true. And just to prove it, we get nothing printed to the console. Now, my example isn't the best demonstration of how a while loop is typically used. One property of a while loop is that it is indefinite in the sense that it's going to run an indefinite amount of times. We don't specify how long it can run because we can just say while true. A better example of using a while loop is when we're working with a server. When we go contact Google, we make a connection to Google and then it spawns a new thread to only talk with us. We're not talking to the main server at Google because otherwise we'd have this big long line of other people that need to do their Google searches. So instead, what they likely have over at Google on their thousands of servers that they have is that they accept a client connection in a while true loop, and then they're going to create a new thread for that specific client. And so then it goes onto a multi-threaded system and handles that client, but then it immediately jumps back up to, let me accept a new client. Let me accept another one. And it just keeps on running because Google servers never shut down unless there is some big error that happens. And so that is a better example of how a while loop works. One thing with a while loop is that they don't always run. So if I had a condition of while I is greater than 0, and we had an integer called I that actually starts at -1, this loop is actually never going to run because I isn't greater than 0. We start at -1, we check this condition and we're like, we're not going to run this while loop. And that can cause some issues, especially if you're wanting to run maybe something like a menu option to a user. And that's where do while loops help us out. Just like I said, do while loops are perfect for presenting a menu to a user and then them selecting something from that menu. So let's go ahead and build a do while loop. The general syntax is to write do, open up the braces, make sure that you close them too, and then we put the condition all the way at the bottom. So here I'm just going to say a do while true loop. So this would run infinitely, but with our common knowledge that we have, we can actually break out of this loop using a break statement eventually under some certain condition. Let's build this menu first. So here's our menu. We can have the user either select for the program to say hello or to say goodbye. But what if the user doesn't enter a 1 or a 2? We would like them to enter some valid response, right? Well, first let's go ahead and get the user's input. So we can just say string input is equal to console.readLine. We're going to print this menu out to the user, and then the program will sit here and hang until the user enters in some sort of string. And what if the string is not a 1 or a 2? Well, let's go ahead and build that if statement. So if input dot equals 1, then we're going to go ahead and print hello. So do a write line and print hello. And we also have to make sure that we close our condition off properly. And then if it's a 2, so else if input dot equals 2, we can go ahead and do a write line that says goodbye. And then we can add some additional logic here and go ahead and break out of the loop. So we can just say break. This is going to be the thing that gets us out of this do while loop. And also, don't forget to actually properly close this Boolean statement up here. But what if it's not a 1 or a 2? Well, we can have our else statement here that's going to save us, and it's just going to say continue this loop. Now, this is actually unnecessary. It's just as if we didn't have this else statement and it would continue to run. So let's go ahead and actually just take this out, and let's actually fix this because this isn't going to allow us to enter anything in LinkPad unless we change this. So let's go ahead and take out this console, and instead let's write util.read line. So if we go ahead and run this program, we're going to get the menu printed out to us. Say hello or say goodbye. You're gonna see all the way down right here, there's this little black box, and that's where we can enter in some input. So what if I hit 1 and then hit the enter key? There we go. The program said hello to us, and then we get our menu choice again. So let's go ahead and enter it in again. Let's try 1. There we go. We get hello in the menu again. What if I were to enter -1? So if I enter -1, as you can see, we just got the menu immediately again. There was no input between these two menus. So that's exactly what we want. We want to make sure that the user is selecting some sort of valid input. And so with this, I'm going to hit enter, or I'm going to enter 2, which then will get a goodbye, and then it breaks out of the loop. And so here we get goodbye, and as you can see, goodbye was printed and the program ended. Now, just like a while loop, a do while loop will run indefinitely. We don't know when it will exit. Obviously, if you give some sort of index-based Boolean expression down at the while loop, then yeah, you'll know how long it will run. But typically, do while loops and while loops, we don't know how long they'll run because we can sometimes just pass in a true or some other kind of condition that we don't know when it will change. Let's revisit that problem where our manager comes back to us and says, hey, I need you to print the array actually from 10 to 1. With a for loop, it makes this process super easy. And actually, the index, our condition, and how we update that index is all in one spot, rather than when we have a while loop where we're using up multiple lines, trying to track, updating the value, and all this other stuff. The for loop kind of keeps it all in one space. So let's go ahead and go over the basic syntax of a for loop. We use the for keyword and then open up the parentheses. Now the first part of the for loop is going to be how we are working with our index and what the index is. So it's typically going to be an integer. So we're going to just call it int I, and we're going to start it at 0 because that's where we want to start at in our array. And next comes the condition that keeps us running in this for loop. And so we'll go ahead and say I is less than the array dot length. And then there's one more thing we need to add to this for loop, and that's how we are updating I. And so we can just go ahead and do an I++ and then open up the braces. And here, all we have to do is our write line statement, printing out the array sub I. Let's go ahead and run this. It's going to print from left to right in this array. Let's make sure that it works. And there we go, we get a 1, 2, 3 all the way to 10. Now, in order to solve this problem of our manager saying print it the reverse way now, all we have to do is say what we did when we had our while loop. It's started at the array.length and then change this to I is greater than or equal to 0, and then change how we update the index there. Let's print it, and we're going to get an error because again, we can't start at 10 when there is no index 10. So make sure that you're doing a -1 there, then run the program. And there we go, we get 10 all the way to 1. Now look at how succinct this was. It's just 4, we have our index here, we have the condition, and we have how we're going to update that index all right in one spot so we can evaluate a loop pretty quickly. And this is just a one-liner for loop. This is really nice. It helps our program scale very well. And a big property of for loops is that they are definite. We know how long they're going to run just by looking right here. Now, we're not constricted to just doing a minus. We can do a plus, we can do a times equal, like we can update the index by multiplying some sort of value. We can also divide too. At the end of the day, just as long as the index is being changed in some way to make sure that we can get out of this for loop at some point, then you're good. The for each loop can be thought of as a super for loop. Let's say that you want to iterate through all the characters in a string or all the integers in an array, but you want to do it without having to track the index, when we need to exit the loop, and how to also update that index, because that's a lot of overhead. Well, we have the for each loop, and its syntax is fairly straightforward. We literally write for each as one word and then pass in some value, and you'll see how that gets made up soon, and then have the braces as usual. So let's say that we want to iterate through all of the characters in a string. Well, let's go ahead and declare a string here called s, and we'll set it equal to colon, all lowercase. Simple enough. In here, we know that strings are made up of characters. Strings actually conform to some interface called the enumerable interface. It's basically something that we can enumerate through. Same thing goes for arrays. We can enumerate through all of the values or the indices in an array. Well, this string is made up of a sequence of characters. So we can just say char c in s. So to read the statement again, it's saying for each character that we call C that is within the S string, we can do some sort of checking with it. So we can go ahead and just do a very basic write line, put in C here. And so let's go ahead and run this, and we should get COLTEN printed on each line. And that actually printed out something from earlier, but there we go. We get the colon string printed out to us. It's very similar if we had an integer array. We can go ahead and call or declare an integer array called array and set it equal to just like 1, 2, 3. So 1, 2, and then 3. And so what makes up this integer array? Well, integers. So we just change this to int. We can rename this to I instead, and then say that we're iterating through array and just write I to the screen. So let's run this. We get 1, 2, 3. Now the drawbacks of a for each loop is that we cannot customize how we're iterating through the loop. It's literally going from the very beginning all the way to the end. We can't track the index, but it still has all the other properties that a for loop has, which is primarily that it's a definite loop where we're going through from the beginning to end, and we can do some sort of operation with each index within whatever construct that we're working in. That covers everything that we have to learn about loops in C#. Remember that it condenses our program and increases programmer productivity. We can take 10 lines of code and put them all into a single line of code wrapped within some sort of loop that you desire. So there's 4 different loops. We have the while, the do while, the for loop, and then lastly, the for each loop. I hope you learned something today, and I want to thank you for watching this video. If you did learn something, maybe consider liking and subscribing for more content like this, and I'll see you in the next one.